Hello my lovelies! Today we're going to talk about composite figures and the perimeter and area of a composite figure. I hope you guys are all staying safe and warm while we're not in school, and maybe even enjoying a bit of a day off or two. So here's the note sheet that we're going to go over really quick. It should only take a couple minutes, but I encourage you to print this out and follow along because we are going to have a note check at the end of this term or this unit in a couple weeks, and I'm gonna try to find these notes and they'll be required in your note check, either like this or handwritten yourself with the information. So let's get started. We're going to start off with what is a composite figure. And so, as I kind of mentioned in the slideshow you should have looked at earlier, a composite figure is a shape constructed from other basic or known geometric shapes, or it's a shape, like this one right here, that can be broken down into our three basic shapes that we're going to go over in just a minute. So, we're going to write in our definition right here, and we're going to say a shape constructed from other basic shapes. Or we could say a shape that can be broken into basic shapes. Probably could have put more room there in that space, but oops. So now we're going to talk about the three basic shapes. So you should have also noticed this in the introductory slideshow that I put in and kind of played along with that, and you'll have remembered, hopefully, that our first basic shape we're going to talk about is a rectangle. And so for our rectangle, we're going to draw a rectangle, and we're going to label this our base and this our height, and we're going to write rectangle. And the formula for rectangle is area equals base times height. And the big thing to remember about rectangles is that a rectangle category also includes squares. And so if we see a square in a composite shape or figure, it would be considered a rectangle, because if you remember, all squares are rectangles, but not all rectangles are squares. So, we have our rectangle. Our other basic shape is a triangle. Triangle. And we're going to write our base. I didn't leave a lot of room, but this right here is our height. Always remember that the height of a triangle is the perpendicular distance straight up from the base of the triangle. So in this case, it's in the middle of our triangle, not this diagonal length. And for our triangle, the area for a triangle equals 1/2 base times height. Our final basic shape is a circle. Beautiful. And we're going to draw a little radius. Boom. We're going to label that R. And for our circle, we know that the area formula for a circle is pi times radius squared. Now the important thing to notice here, because we're also talking about perimeter, and what do we know about perimeter for a triangle and a rectangle? We just add up their side lengths. So say this was 2, and this was 2, and this was 4, and this was 4, we would add 2 plus 2 plus 4 plus 4. In the triangle case, it's the same deal, so we just add up whatever the side lengths are. For a circle, we need a formula for that. And if you remember that formula, our perimeter for the circle would be pi 2 times pi times the radius. And so we're going to need to note that too, because it's very important to remember. Because unlike a triangle and a rectangle, we have to use a formula to find the perimeter, and that may be needed when we get to later examples. So now, how do we find the area of a composite figure, or a composite shape? The first step is to break it down into our basic shapes. So the first thing we need to do is take our big shape, like this example, and break it down into our smaller shapes, our rectangles, triangles, and circles, whatever is necessary. And so the fun part about breaking it down is that there can be multiple different ways that you can break down this shape. I'll show you later in this example, but there's not always one exact correct way to break down a shape. As long as you can break it down into the 3 basic shapes, you're doing it correctly. So step 2, what do we do after we break it down? After we break it down, we want to find the area of each piece. So we've broken it down into our basic shapes, and we know the formulas for our basic shapes. Now we're going to find the area of each basic shape within our big composite figure. And after we find all of the pieces, the area of all the pieces, we're going to add up those pieces. Now, an important thing to note with adding it up at the end and figuring out what the whole is, there are situations where you're actually subtracting certain areas. And I'm going to let you guys kind of explore that in your practice and in your worksheet with your groups. But there is cases where you're subtracting instead of adding. So let's see if you guys can figure that out, and we'll talk more about that when we're together. So now we're going to do an example, and I'm going to break out some fun colors. So the first thing we should talk about is our first step. So we have our shape, and we want to find the area. In order to find the area, we need to break down our shape into our 3 basic shapes. And so I'm looking at this, and I'm not seeing any curved edges, which means we probably won't use any circles. So that makes me realize that we're only going to use rectangles and triangles in this shape. Now I'm looking, and to me, I see a line that can be formed here, and we get this rectangle, then we would also have this rectangle, this rectangle right here, if I put a line there, and this triangle. So I've broken down our pieces into our pieces. So that's step 1. Step 2. Now we got to find the different areas of each different piece. So I'm going to label this piece A, this piece B, this piece C, and this piece D. And I'll still use the colors just to help. So we're looking at piece A first. Oops, I used a color twice. We're going to make D yellow. We're going to try. Okay. Alright, my bad. So starting with piece A. Piece A. We want to find the area of this piece. And we know that's a rectangle, which means it's going to be base times height. And so our base in this case is 3 centimeters. So we have 3 times. Well, what about our height? It's not labeled because it stops here, and this 17 is for the whole edge. Well, if we look, we see that this whole edge is 17 centimeters. And this piece right here has a height of 9 centimeters. So whatever is left over is going to be the rest. So 17 minus 9 gives us 8. And so this side length is 8. And if we multiply 3 by 8, we get 24 centimeters squared. So that's piece A. Now we do piece B. And piece B also happens to be a rectangle. And so we're going to do base times height again. In this case, our base is 25 centimeters. Now pay attention, it's not 11 because this piece is 11. But the whole base is 25. So 25 centimeters times our height, which, as we saw earlier, is 9 centimeters. And so 25 times 9, if we break out our calculator or do it quickly by hand, we should get 225 centimeters squared. Now we move on to piece C. Piece C is also a rectangle. Lots of rectangles is in this one. So again, we're going to do our base times height. And our base in this case is 5 centimeters. Now what about our height? It's not labeled. But if we remember, on this side it was 17 centimeters. And this side is also 17 centimeters. And like we remembered from the height of this piece, it's 9 centimeters. So the leftover is going to be 17 minus 9, which, as we learned earlier, was 8. And so 5 times 8 is going to get us 40 centimeters squared. And our last piece, we're almost done. Our last piece is piece D. And you probably cannot see that, so we're going to use our pen. It's piece D. And so piece D is a triangle. And so now we have to switch gears. Remember, the area for a triangle is 1/2 times our base times our height. So we have 1/2. Our base is this length. Well, we don't have that length. It's not labeled. Well, this is going to be a little trickier. It's not as easy as looking at two numbers. We have to think about the whole length and what we have. And so this whole length is 25 centimeters. And we just want this piece. Well, do we have the rest of the pieces in order to find this piece? In this case, we do. We have this, which is 11 centimeters, plus our 3 that are down here that we could move up. And then we would have 11 plus 3, which is 14. And then we also have this piece, which we could move up. And that's 5 centimeters, leaving us with this piece blank. So 11 plus 3 plus 5 gives us 14 plus 5, which is 19. So 25 minus 19, which is what we already have, will give us 6 left over for our base. So our base is going to be 6. Now for our height, once again, we have this much left over from a full length of 17. And so 17 minus 9, my bad. And we already know, once again, that is 8. And so when we do our math in our calculator, we'll end up with 24 centimeters squared. Now, our last step, we're going to add all the pieces together. In this case, all of our pieces are simply added together. And so A plus B plus C plus D, which we know equals 24 plus 225 plus 40 plus 24, which, if we use our calculator and add that all together, we end up with 313 centimeters squared. And remember, we want to always remember our units, and we're going to use centimeters squared because we are using 2 dimensions and our piece is flat. It's not 3D, it's not sticking out, we have 2 dimensions. The length and the width, or the base and the height of our figure. And that is how you find the area of a composite figure. Hopefully that makes sense. If you guys have any questions, feel free to email me or to talk to your group mates. There are some practice problems available and some group practice problems that you're going to have to do in order to receive credit for the day. I hope this helped you guys out, and I can't wait to see you soon. Bye!